Hello, my name is Aaron Park, and this is 7th grade, lesson 34. So, for our first word problem, Jackie has 5 bottles of lemonade on her lemonade stand. In order to raise money for her dance club, she needs at least 100. A pack of lemonade contains 12 bottles. How many packs of lemonade does Jackie need to get to her minimum number? Well, assuming that this is at least 100 bottles in total, we want 100, or not just 100, at least 100. This means that instead of using an equal sign, we will be using a less than symbol here. 100, we have to have at least that much. At least 100. So, one pack, we can use a variable to represent the number of packs. One pack is 12 bottles. So, that means for each P, let's say, we get 12 bottles. So we put the coefficient there. But we also start with 5 bottles on her table. So we add 5. Now we solve this inequality. First we isolate the term with the variable, subtracting the constant out. 95 is less than 12p. Then we divide by the coefficient to get p is greater than. Be mindful of the sign here. This mouth is pointing toward the p, so we keep it that way. And then this is a nasty number. Let's try using long division to find it. But since we'll be using whole numbers, since you can't buy half a pack or 0.349 or whatever of a pack, we don't need to do that much work. First, we can see that 12 goes into 95. Not quite 8 times, it's 7 times. 7 times 12 is 84, leaving us with a remainder of 11. So, if we bought 7 packs, we would only have 84 plus 5 is 89, which is not at least 100. If you buy 8 packs, we would have 96 plus 5, 101 packs, which is 1 more than we need. And that is at least 100. So, not 7, but 8 packs must be bought to get to her minimum number. P is greater than 7, and then another way to think about it is you could keep doing it here, going to the next decimal place, the 10th place. We bring down a 0, 9, 96, and then subtract, it'll get something. It doesn't matter. You'd write 7.9 here, and it needs to be a whole number, so the next whole number that's greater than 7.9 is, of course, 8. We'll skip number 2. Number 2 is not a word problem, but simply just some math for you to do. Number 3 is a word problem. There are 3 bikes and X cars in the body shop. What must be the greatest number of cars so that the number of wheels is less than 31? First of all, let's identify how many wheels a bike and a car have. A bike has 2 wheels each, and a car has 4 wheels each. Now we have 3 bikes, so we have 3 times 2 wheels. And we also have 4 times X other wheels from the cars. What is the greatest number of cars we can have while keeping the total number of wheels less than 31? Wheels less than 31. Well, we have 31 here, and now we're going to have a greater than or less than symbol. Reading it again, it is clear that, well, if you want the total number to be less than 31, that's what we want. We want it to be less than 31. 3 times 2 is 6. So, just like before, we isolate the term with the variable, subtracting 6 from both sides to leave us with 4x is less than 25. divide by 4 to get x is less than not quite 6. It's a little bit over 6. It's actually 6.25. But that's good for us because you see we can't have 6.25 of a car. We have to have a whole number increment of cars just like before with packs. So that means 6 is a possible value for x because x is less than 6.25 when it equals to 6. 6 is less than 6.25, which means the greatest number of cars we can have in the body shop while keeping the total number of wheels less than 31 is 6 cars. Checking our work. 6 cars, each with 4 wheels, is 24 wheels, plus 6 is 30 wheels in total. That is less than 31. An interesting name, Shivan, has 100 flowers. How many bouquets of 7 flowers can she make? Well, let's just perform division. The reason we know that is, if you want to write it out, we have 100 flowers. And then we can use unit cancellation. So you multiply 1 bouquet is 7 flowers. Now, the way unit cancellation works is we can check to see if we set it up correctly by canceling units, just like how you'd cancel, cross-cancel. And then you can see that we are left with only bouquets. That is our unit, which is good, because we are asking how many bouquets we can make. So we just perform 100 divided by 7. Well, let's write it out here on the side. Long division, 100 divided by 7. 7 goes into 10 one time. 7 goes into 30 4 times. And then we're left with a remainder of 2. We have 2 extra flowers, but that isn't enough for another bouquet. So we can only make 14 bouquets with 2 flowers left over. You can give these to your friends, I guess. Now then, I'll leave this word problem to you, and we'll go over to solving the equation. Here we have 2 binomials being multiplied together, and it is set equal to 0. So, we know that anything times 0 equals 0. 2 times 0 equals 0. Well, the same is true even with variables. So that means that since we have 2 things multiplied together, if one of them turned into 0, the entire thing would equal 0, and this equation would be solved. So we are going to look for the x values that make either of these values, so either of the things in the parentheses, equal to 0. For instance, looking at the first problem, we want one that makes x minus 5 equals 0, or one that makes x plus 3 equals 0. Either would work, because if either of these are true, then one of these is 0 now, and 0 times anything equals 0. So, the actual sub-equations here are easy to solve. You move the constant over to the other side to get x equals 5, or x equals minus 3. Now you might be asking, which one is the answer? Well, the answer is, they both are. The equation has 2 solutions, x equals minus 3 and x equals 5. Both of these are correct. In fact, omitting one of these, so if you forget to write one, would mean you haven't found every solution. You're technically wrong. You can check your work by plugging these values back in. So if you plug in 5, we get 5 minus 5 times 5 plus 3, which is 8 times 0, which does indeed equal 0. Same with negative 3. We can solve the rest similarly by setting what's in the parentheses equal to 0 and finding our 2 answers. I'll leave the rest to you. Thank you.